In this video, I'm going to talk about thresholding, which is the simplest method of image segmentation. The principle is very simple. We start from a grayscale image, and using thresholding, we produce a binary image, either black or white. So the process is the following. If a pixel is greater than a threshold value, then it will be assigned a certain value, for example 255, to assign it as a white color. And if it is lower than a threshold value, then it will be assigned to another value, for example 0, to make it black. And there are two different types of thresholding: the simple thresholding and adaptive thresholding. Simple thresholding, it uses the very simple formula, as I already explained. If the pixel is greater than a certain threshold value, then it will be assigned to a white color, 255, and if it is smaller than a threshold value, it will be assigned to a black color, to 0. And in OpenCV, we use the method cv2.threshold, and it takes as input the gray image itself, and then the threshold value, which is a value between 0 and 255, the maximum value. So typically in a grayscale image, the maximum value is equal to 255 because the color is encoded on 8 bits. And finally, the threshold style. And there are different threshold styles predefined in OpenCV. We have a threshold binary, which is very simple. So for every pixel at position X and Y, if the value of the pixel is greater than the threshold, then we will assign the maximum value, which is 255, which means white color. And if the value of the pixel is smaller than the threshold, we will assign 0. Another style is threshold binary inverted, and here we will do the opposite. If the pixel value is greater than the threshold, we will assign it to 0. Otherwise, we will assign it to the maximum value, 255. We have also threshold trunk, and for every pixel at location X and Y, if the pixel value is greater than the threshold, it will be assigned to the threshold value, and if it is smaller than the threshold, it will just keep the same value of the pixel. So here, some parts of the image will be truncated, will be replaced by the threshold value. And we have threshold to 0, which acts similarly to the trunk, but here we're going to assign 0 if the pixel value is smaller than the threshold, and it will keep its own value if the pixel is greater than the threshold. Simple thresholding is pretty much simple, but it may not be good in all conditions, especially if the image has different lighting conditions. A better approach would be to use the adaptive thresholding, and here the algorithm calculates the threshold for a small region of the image, and then different thresholds will be calculated for different regions on the same image, and thus this approach will have a better robustness to varying lighting conditions. In OpenCV, we use the method adaptive thresholding, which takes the gray image as input, the maximum value, which is typically 255, and then the adaptive method type, and here we have two different types. It can be adaptive threshold mean C, where the threshold value calculated is the mean of the neighborhood area. So here is going to take the mean value of the neighborhood area of interest. And another adaptive method is to use the Gaussian method. And the threshold value is the weighted sum of the neighborhood values, where weights are a Gaussian window. It takes also a block size, which decides about the size of the neighborhood area, how many pixels we take in the neighborhood. And the constant C, it is just a constant which is subtracted from the mean or weighted mean calculated. You can see here in the image the impact of different thresholding. So you can see in the original image we have some shade distributed all over the image. And when applying global thresholding using simple thresholding with the value of the threshold equal 127 is going to give this binarization of the image, which is not acceptable. However, if we use adaptive thresholding, so this is using the mean thresholding, and here we use Gaussian thresholding, so we can see Gaussian here provides a little bit better performance as compared to the mean, but probably this is not a rule, so it might depend from one image to the other, but here the adaptive thresholding is clearly better than the global thresholding. It has to be noted that thresholding is an important technique in computer vision, and this step is necessary in many applications such as contour detection, which is going to be explained in a future lecture. So now let's see how it works in practice. Let us consider the file image_thresholding.py, where I'm going to present how to perform thresholding both using simple thresholding and adaptive thresholding. So this is the main function. I'm going to explain the code. So first we specify the image name. So I'm going to use two images, shapes and tomato. Okay, so let me start by tomato here. And then first of all, we need to read an image as grayscale image. I have created the method read image. Okay, and you can see here, this is the method read image. It takes an image name, and here I specified a Boolean variable as gray. So if as gray is equal to true, we're going to read the image as a gray image. And for this, we can use cv2.imread, the same method that we used before. And then we specify the image name. This is the path to the image. And here we specify a flag that is called imread grayscale. So in this case, the image is going to be automatically converted into a grayscale image, even if it is a color image. If you want to read the image as a colored image, in this case, you can just either keep the default flag, or you can specifically specify that you want to use the flag cv2.imread color. Okay, so in our case, we're going to use the flag imread grayscale just to read the image as grayscale image. If you have read the image as a colored image, in this case, you may need to use cv2.convertImage, and you can convert it to a grayscale as we did in previous videos. And here we're going just to show the image itself. So let me call this as image. And then we will take this gray image as an input to the method basic thresholding. Okay, and here I will specify a threshold value. So let's say the threshold value is equal to 115. We can change it actually. So I'm going now to disable the adaptive thresholding. And basic thresholding, it's going just to call the OpenCV method cv2.threshold. So this is the method I have explained in the slides, which take a gray image, not an RGB image. So this one should be gray. And then the threshold value, which is an input here of the method that we define. The maximum value is equal to 255. And here we're going to choose threshold binary. So let's first choose threshold binary, and then we see what happens. So you can see now I'm going to display the image after that. So let's run the code, image thresholding.py, and here you can see this is the grayscale image, okay? And this is the basic binary image after conversion. So let's apply this one on the shape image. I'm going now to try on the shape image. Okay, this is the grayscale image and this is the shape image. You can see now only the square shape was discovered. Why? Because this one, it has a high value of the threshold. So if we decrease the threshold value, or if we increase the threshold value, for example 200, so it becomes brighter. In this case, we can detect more shapes, as you can see, because we have considered brighter pixels in the thresholding operation. So here basically what we want to have a black background and a white, and the shapes are colored in white. In this case, what we can do, we can just invert. Okay, so instead of using threshold binary, we can use threshold binary inverted. Okay, and just running the same code, you will see now it's completely inverted. What was black becomes white, and what was white, it becomes black. And basically, because later on we are going to use the thresholding for contour detection. In contour detection, we need to make sure that the background is black. So I'm going to keep the thresholding style to threshold binary inverted. So you can see with adaptive thresholding, we need to play a lot with the threshold value in order to detect objects. And this is why adaptive thresholding is much better. So let me put this back at 115. And as you can see, only one shape was identified by the mask. And now we can use adaptive thresholding. Okay, and here we can identify all the different shapes. We can find some holes here, but we can play with the value. For example, I will decrease the value for darker cells. So you can see with adaptive thresholding, we're able to detect the shapes contours here. But of course, with very low threshold values, all the shapes will be considered as black. So adaptive thresholding, it uses the method adaptive threshold, which takes the gray image, and then 255 is the maximum value. Here I have used a Gaussian method for the computation of the adaptive threshold in every region. We used threshold binary inverted and the threshold value, which was defined over here. Okay, we can also use the mean just to see what it looks like. Okay, so similar behavior. Now putting back the default value. So you can see with the mean, we are still able to identify the different shapes. Let's apply this on tomato image. This is with binary thresholding, and this is with adaptive thresholding. So you can see with adaptive thresholding, it really looks much better. So you can see here the effect of illumination. It is more negative with the simple thresholding, and it is much better managed with the adaptive thresholding. So in summary, thresholding is a simple operation for image segmentation, which takes as input a gray image and produces a binary image. And this binary image is actually useful in several applications, in particular contour detection. So in the next videos, I'm going to talk about contour detection, which is also used in a more general context of object detection based on the colors.